Welcome to all. Today we discuss about the topic how to find the characteristic equation for 3 cross 3 matrix and eigenvalue, eigenvector. In generally we write for the characteristic equation for 3 cross 3 matrix. So lambda cube minus s1 lambda squared plus s2 lambda minus s3 equal to 0. Where s1 is nothing but sum of the main diagonal element, s2 is nothing but sum of the minor of the main diagonal element, s2 is nothing but determinant of the given matrix. Then eigenvalues, we solve the characteristic equation, we get the roots. Eigenvector a minus lambda into x is equal to 0. We take example problem for 3 cross 3 matrix. Find the eigenvalue and eigenvector of the matrix. First row 2 0 1, second row 0 2 0, third row 1 0 2. Then general form of the characteristic equation, lambda cube minus s1 lambda squared plus s2 lambda minus s3 equal to 0. s1 is nothing but sum of the main diagonal element. So 2 2 2 is the main diagonal element. So sum of this one. So s1 become 6. s2 is nothing but sum of the minor of the main diagonal element. So first main diagonal element 2, the minor of the element 2 0 0 2, sorry, plus second main diagonal element 2, the minor of the main diagonal element, so it's become 2 1 1 2, plus third main diagonal element 2, then minor of the main diagonal element 2 0 0 2. After that determine this one, we get s2 is equal to 11. Then s3 is determinant of the matrix, it's become 6. After getting s1 and s2 s3 value, apply in this general form of the characteristic equation, we get the respective matrix corresponding characteristic equation, that is lambda cube minus 6 lambda squared plus 11 lambda minus 6 is equal to 0. After that, solving characteristic equation, we get the roots. Here characteristic equation, third degree equation. So third degree equation we cannot directly factorize. So using trial and error method to find the initial root. So that lambda is equal to 1, apply in the characteristic equation. This condition is valid, so that lambda is equal to 1 is the initial root of the characteristic equation. So lambda is equal to 1, write it. Then after that, lambda cube coefficient is 1, lambda squared coefficient is minus 6, lambda coefficient is 11, then constant is minus 6. Then according rule here put 0, then product of this value is 1, here write it, then sum of this one minus 5, product of this one minus 5, sum of this one 6, product of this one 6, sum of this one 0. This method is synthetic method. Okay, after using synthetic method, the third degree equation become second degree equation converted. So this is the constant lambda squared. According to write it, lambda squared minus 5 lambda plus 6 equal to 0. Then solve this equation, we get the roots. So lambda is equal to 3 comma 2. Therefore finally we write for lambda is equal to 1 comma 2 comma 3. Third degree equation, definitely 3 roots should be there, no doubt. Then next to find the eigenvector. Eigenvector, so a minus lambda I into x is equal to 0. A is nothing but given matrix, minus lambda into I is nothing but corresponding unit matrix into column vector x1 x2 x3. Then simplify this equation, simplify this matrix, we get the equation 2 minus lambda into x1 plus 0 x2 plus x3 equal to 0, 0 x1 plus 2 minus lambda x2 plus 0 x3 equal to 0, x1 plus 0 x2 plus 2 minus lambda x3 equal to 0. We call the equation number 1. Next we find the eigen vector, first vector. Case number 1, we take lambda is equal to 1, substitute in equation number 1. So we get the 3 equation. In this 3 equation, you select any 2 distinct equation. So that second equation and the third equation are distinct. So we select second and third. After that, using cross product rule, then we get for first eigenvector 1 0 0. In similarly, case number 2, lambda is equal to 2, substitute in 1, we get the 3 equation. In this 3 equation, we select 2 distinct equation. After that, using cross product rule, we find the second eigenvector x2 is equal to 0 1 0. Then case number 3, lambda is equal to 3. In equation number 1, we get the 3 equations. So we select 2 distinct equation. After that, apply cross product rule. Then we get the third eigenvector x3 is equal to 1 0 1. The final conclusion of this problem, the characteristic equation of the 3 cross 3 matrix is given. So that is lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. The eigenvalue lambda is equal to 1, corresponding eigenvector x1 is equal to 1 0 0. Then lambda is equal to 2, the corresponding eigenvector 0 1 0. Then lambda is equal to 3, corresponding eigenvector 1 0 1. Thank you.